All right, today I'm going to ruin everything for you because you love theme parks. Theme parks are nothing but Newton's laws of motion. Okay? Now, we just read through the pages 66 through 73, and we talked about Newton's three laws of motions. Now, the first thing that they talked about before they got into Newton's laws was acceleration. Acceleration, this can be a little bit tricky for you. Acceleration is a change in speed or direction. Change in speed. The way we always think of acceleration is step on the gas and go. And that's acceleration. But if you are going really fast and you take your foot off the gas, aren't you changing the speed?
Yes.
So that is acceleration also. Even though you're slowing down, it's still acceleration. It's a change in speed. If you make a turn, okay, you're going the same speed, okay, but you make a turn, that's acceleration also. It's a change in direction. So acceleration is a change in speed, up or down, okay? And it's a change in direction, one way or the other. Now, when we were reading about it, we also moved into talking about, in Newton's first law, we talked about inertia. Okay? Newton's first law of inert is an object in motion will stay in motion unless something works on it. Something does something to it. You know what this is a prime example of? It's going to ruin your life. It's a roller coaster. Because that is, Newton's first law is what roller coasters were made from. Okay? Yes, cover your ears. You don't want to hear this. It's going to ruin going to Disney, going to Universal, going to Busch Gardens.
No, thank you.
All of these. But in this, if you are in those theme parks and you get on a roller coaster, Megan, listen. And you get on the roller coaster. The roller coasters first start out with you pulling away from the gate. Okay? Then it either goes up real slow, or if, some of them will sit and go boom, and you'll just go straight down. Now, if you are going up, okay, your body's wanting to go down, okay, because you're changing direction, okay? And so once you get going up, once you get at the top, then it's like they sit and dangle you and make you look down there and you go, oh no, I'm gonna die, oh, no, and you put your hands up and it's like scream and yell, and, yeah!
It's so fun.
What happens?
I always put my hands up.
You have to sit and think about this part. When you go over the top and you go down, what is your body doing?
Is your body trying to fall forward?
No.
Your body is going up since you were going up, and then because of inertia, and then you fall back down.
But when you're going down the hill, where is your body going?
Up.
Where is it wanting to go?
It wants to go up.
It's going back into the seat, right? Going up. Okay? Because you are going at such a speed that happens. Now, when you get at the bottom and it comes back up, what does your body do? This is the cool part. No, you get down there and you go down through and your body just keeps going. You sink in your seat as it's going back up. Okay? Because your object in motion wants to stay in motion. When you're going down that slope, okay, it's going to want to keep going down. but all of a sudden the roller coaster goes up and you just sink in your seat. Okay? When it makes a turn, you go flying over here. But wait, it's turning this way. Why are you going this way?
Your body wants to keep moving the way you're going.
It's wanting to keep going straight. If you're going straight and all of a sudden it turns, you're going to go into the side of it because your body's still wanting to go in that same direction. Okay? Here's one for you. This is your homework tonight. This is fun. This is a fun homework.
Sit in the chair and spin around.
No.
As
No.
you can.
I'm the driver.
Okay.
Okay? You're the passengers. Okay?
I'm very
You're in the
sorry.
car. It's going to be a bus. Mr. Mink's magic
School
school bus. Yeah. Okay? So we're in the magic school bus. We step on the gas. What do? You go flying back. Why are you flying back?
Because you're like right here, and then you start going forward, and then your body moves back.
But what was your body wanting to do?
It wanted to stay as a uniform motion.
It wanted to stay still. You started out being still. Then all of a sudden, the bus is accelerating forward. Okay? And so what happens is you're going to go like this because you're wanting to go back to that spot where it was just sitting still. Okay? That's what your body is trying to do. Mr. Mink's driving along. Turns this way. Where do you go?
This way.
Why are you all turning that way?
Our body wants to keep going straight, but the car moves.
Your car is going this way, but your body was going in a forward motion. It's wanting to keep going in that forward motion. Okay? Now, when I went to school at Florida State, I lived my senior year off campus, and I had to drive from my apartment to the school, and there were these back streets that I drove through because it was a lot quicker, it was more direct. One of them, you start at the top of a hill, and there was a stoplight. You go down the hill and back up, and on the top of the other side, there was a stop sign. But this hill was great because you would go down it and back up. And what did you do in your car? You're sitting there driving, you're going down. You start going back up and you sink in your seat because your body is still wanting to go down when it's going back up. Okay? This is all part of Newton's first law of motion. An object in motion stays in motion. An object at rest stays at rest. Okay? Unless something acts on it. A force acts on it. Your homework tonight. You all have to go home, right? Your homework will be done before you get home. Because what you are doing is you are sitting in your family car. And the object of this is to feel this motion. You have to close your eyes, okay? And part of it's try and figure out, all right, what street am I on? But what you're doing, the reason I want you to close your eyes is because I don't want you seeing what's going to happen, okay? But I want you to feel your body, okay? And what you're actually feeling is the movement from side to side, stepping on the gas, stepping on the brakes, stepping on the gas, okay? When your mom pulls up to a stop sign or to a stoplight and the light just turned, she's stepping on the brakes so that she stops before she gets there. You're going to want to go forward. Why?
Because your body is moving forward and then it stops, and your body still wants to go.
Your body still wants to go, okay? So you're going to feel that. Then you're going to feel her accelerate, take off. You can go back in your seat. She's gonna make a turn to the right. You're gonna go to the left. Okay? All that you are doing is you are going and you are feeling these motions. Okay? Sometimes, if you guys go to Disney, when you get over to, I think it's around Lake City, where those big, their telephone,
Oh, with the
Or
Mickey Mouse.
with the
face?
Mickey Mouse
Yeah,
ears.
Oh,
Yeah.
and
Right.
then there's that big turnaround.
No, but right on I-4, as you're going over there, there's a little dip in I-4 right there.
I went there.
And as you're going through there, your car goes down, it comes back up, and you go down and you come back up. Okay? It's a dip. Try and see if you can find where there's a dip. If there may not be when you're going home. But you will feel the left, the right, the turns. You'll feel the acceleration. You'll feel them stopping. All that you are doing is you are finding these motions. Remember, inertia is wanting to go in that same direction that you're going, in the uniform motion. Okay? Uniform motion is just going in the same direction, same speed, constantly. Okay? Now, when you get on an escalator, from the top to the bottom, if you just stand on it, you are in uniform motion. You're going at that angle straight down. When you get at the bottom, then your motion changes.
Excuse me, Mr. Mink.
Yes,
Liliana Kreisel's, her lunch is up in the office.
she's in Miss Galley's class.
Oh, okay, I'm sorry, thank you.
It's all right. Questions on first law?
Like when you get into a car accident, is that why some people like fall forward because they're
Yes.
moving and then they like stop?
It is. That is where the crash test dummies come in, where they put them in a car, and all of the car makers will take these cars and crash them. And they're doing it for your safety, okay? Because if they crash them, that's when they find out where there's a weakness, where there's something wrong, if it blows up. You know, they don't want it doing all these things. And so they will do that. They will also put the crash test dummies in there, fake people. And they will buckle them in and watch how they move in there. Okay? They will help with their restraints, with seat belts and things like that. But there's one of those car commercials. It's not a car commercial, it's an insurance one, or maybe it's just Click It or Ticket, where they tell you to put your safety belt on. There's this couple, young couple, and they're driving down the street. They're looking at houses and saying, oh, they would like that one. A car comes out in front, it hits them. The guy goes flying out the front windshield.
No.
And they stop it right before he hits the ground. And then they back it all the way up. And he gets back into the, reverses it, puts it all the way back into the car, back up, and then they show him clicking his safety belt. Okay? That is the same thing as Newton's first law. His body was in motion, going 30 miles an hour, 40 miles an hour down the road. Runs into a car. He didn't have the safety belt on. His body is still going to want to go at 30 to 40 miles an hour. And it's going to go flying through the windshield. Okay? That is Newton's first law. Okay? That's the ugly side of the law. But the funner side is the theme parks. Okay? And understanding that. So tonight, your homework. When you leave, you get in the car, close your eyes.
That's our homework.
Yeah, and feel the motion. Feel your parents turning, and you can sit and figure out if they're slowing down, if they're speeding up. It's better if you sit in the middle seat, in the back, because then you're not leaning on the door or whatever, and you can feel the motion, okay? They're showing in here bowling. I mean, you talk about ruining everything. Now when you get out here and play kickball, it's going to be completely science.
No,
It's all that it is.
No.
Newton's second law. Newton's second law has two parts to it, okay? One part is the same force and a different mass, okay? And the other one is a different force, but the same mass, okay? In other words, if I had Luke Spence up here next to me, and we had Ethan pushing at the same rate on both of us, who is he going to move? Probably Luke, because Luke has a lighter mass than what I do, okay? Less mass, more mass, okay? Same force that he's pushing on each one, it's going to be different. They show it in the book at the bottom. You got that huge yacht, and then you got that little
Canoe.
dinghy, we're going to call it. And if you were to take that motor, we're going to say that it's a 15 horsepower motor, and you put that motor on the back of the yacht, it will move the yacht, but oh so slowly. You put it on the back of that dinghy, it's going to move right along, because it's the same force, it's the same 15 horsepower motor, but when you put it on something that's a lot less, it's going to move it a lot more, a lot faster, okay? Then they talk about the same mass, okay, and different forces. This they use the archery. The arrows are all the same mass, okay? It's the force that you're putting on it. Usually with archery, there is a distance that they have to go, and so you're going to run into a little bit of gravity, and if there is any wind, you got that playing into it also. And so what they're going to do is they're having to put a certain amount of force on it to get it to go that distance, okay? And if they put the same amount of force on each time, or different forces on, it's going to go different ones. We talked about ski jumping, okay? And if you don't have that much force, that much acceleration, you're not going to go that far. The next time you go, okay, if we make it you doing it twice, the first time you don't have that much force behind you, the second time you do, you're going to go much farther. Okay, Liam?
When I was skiing, I tried to do a little like stinky jump thing, thinking that it would send me like maybe 4 feet.
Mm-hmm.
It launched me, cause I was going, but it was like very steep, so I was like that, and I had expected to go like that, but I just went.
Yeah. You'll find out how much force you really had going. Yes.
Another way you could you could explain it is with golf.
Mm-hmm.
If they go all the way back, they're gonna use more force and it's gonna go further. But if they're like putting,
Even if you're putting, even if you're just putting, and from here to the door is where you're putting to, okay? How much force am I going to need to put on it?
not a ton.
Not a whole lot. Christian is back there. We're hitting the same golf ball. Is he going to have to put the same amount of force?
He's going to have to put more force.
He's going to have to hit more force, okay, to get it in from there than I would from here, okay? Now we're going to move on to the third law of motion. This is an object at rest, stays at rest. Sit still, don't move. Ethan is at rest, he's staying at rest. Okay? Now, an object in motion is going to stay in motion unless something acts on it. So when you're out playing kickball, when you're out playing kickball, you kick the ball and it goes in motion. Okay? It's going to stay in motion unless something acts on it. What are some of the forces that are acting on it?
Gravity, friction, and if the person touches the ball.
Something touches it. Now, friction could be anything from air, okay, wind, because I think it's windier today than what it has been. It was windy yesterday. The wind is actually a force on it. Gravity is actually a force on it, okay? Those are things that are going to change the motion of it, okay? Now, we get into Newton's. This is what you guys have been waiting for, okay?
Yeah.
Yes.
Okay? An object at rest stays at rest. Is anything happening?
Nope.
Nope. Moving a little because I put it down. Okay? Now, all weekend long it was sitting back there. Was it doing anything?
No.
An object at rest stays at rest. Allison's Bible sitting on her desk. An object at rest stays at rest. Unless a force acts on it. Oh, I moved it. I was the force, I moved it. Okay? All I had to do was just move it a little. That's the force acting on it. Okay? Now, this is where it gets fun. This is how science is fun. Because with roller coasters, all that roller coasters are Newton's laws of motion. Ramped up. They've jacked them up, you know, it's like buying an F-150. You buy a regular F-150, and then you say, well, what can I do to it? Oh, let me put some lights under it. Let me put some big wheels on it. Let me jack it up a little bit. Okay? You do a lot to it. Well, that's the same thing with these roller coasters. All that they do is they take them and they make them more and more forces. The more and more forces that your body goes through, the more fun you have. That's all that they are. Okay? Now, let's see what happens. Equal and opposite force. Okay? One ball on one end, one ball on the other. The other three stay still. Okay?
Oh shoot.
That's the
Two at a time.
equal and opposite force. Okay? Let's move on. 2. Just hold still.
This is gonna be
Let
good.
them move. Equal and opposite. Okay? 2 on one side, 2 on the other side. 5th one in the middle stays still. Okay? We've done 1. We've done 2.
3.
Let's
Yeah.
try 3.
Oh, this is gonna be cool.
This is where you gotta pay attention.
This one is really cool.
So it's taking one.
taking one and
the
then-
other.
The middle one goes both ways.
They're trading it.
Okay?
Here you go. Here you go.
Four.
I'll try it again.
They're gonna share now.
Yeah, share.
Ooh,
They're trading.
trading. And after a few moments, they share. Yeah. This is very fun to watch.
Now do 4.
All right.
4.
4. 4. 4.
5 would be very boring.
5 would just go.
5 would just
Oh,
go
5
back
would just
and
go.
forth, back and
I know,
forth.
it's so boring.
Yeah. Oh my god, look at that. The other two.
It's hard to do it because it's not.
That wasn't as satisfying as I
Oh my gosh, look,
95.
the thing is moving. The thing is wobbling on the. Yeah, I know. It's just funny.
Because the chair has a butt.
I know, it's just funny. Watch, watch.
This is 4 again.
That's so cool.
4 one way, 4 the other way. Equal and opposite directions. Okay?
Equal and opposite reaction.
Christian, do you have a question?
With golf, doesn't it have like potential energy when you pull it back?
Yes, but we aren't getting into that right yet. Okay? Now, things that you need to know from this lesson. You need to know about acceleration. Acceleration is speeding up or slowing down. It's turning right, left, up, down, any change in direction, change in speed. Okay? Uniform motion is when there is no change in speed or direction. So they gave an example of being in a train and you're out in the middle of the plains and you're going along straight. It's just a straight shot. And that is uniform motion. Okay? I know when I went to Atlanta different times and you go in the airport, you can get on the trams that are down below that take you from A to B to C to the different ones, or you can walk. And when you get on there, there's a walk thing that it's sort of like an escalator, but you're not going up or down, it just moves you along straight. Okay? If you stand on that, yeah, if you stand on that and if you stand on it, it goes at a constant speed in the same direction. That is uniform motion. Okay? Where you're going in the same direction, the same speed. Okay? That's uniform motion. Then we talked about Newton's first law of motion, where an object at rest, no. This is where an object in motion will stay in the same speed or direction unless something acts on it. This is where inertia is. Okay? Second law had 2 parts to it. Okay? One was about force and mass, and the other was about mass and force. Difference. And the third law is states that an equal everything. This was the bumper cars one. This is where you stay in motion unless something acts on you. Okay? And that's it for today. Don't forget your homework.
What about the hurricane? Isn't it kind of